This project is the design and development of in-mold assembled scissor tongs. So for some background about this project, the Plastics Training Academy submitted this project to prove the concept of in-mold assembly using the same material through a two-shot process. So to talk about some specifications, one big specification was that the tongs must hold a 38 millimeter thick 454 gram steak. The selected material must be dishwasher safe, as well as no sharp edges or visible ejector marks. So going down to the molding process, step 1 is actually molding the first half of the tong. Step 2 is removing the gate and placing the first half of the tong into the in-mold assembly version of the mold. And step 3 is actually creating the overmold between the two halves through a joint, creating the full assembly. The two-shot process eliminates the need for secondary operations, as well as our design is equipped with an ergonomic handle, and the tong heads increase surface area contact with use, and our mold design was designed for the ease of machinability and cost reduction.
To validate our design, flow analysis was performed to find a suitable gating location that would place the weld line around the handle in a proper area where it would be able to meld together instead of the two flow fronts colliding head-on, which would lead to early failure of the part. Finite element analysis was also used to simulate the stresses placed on the tong when in use. The scenarios that were analyzed were when the tong experiences regular stress, and another scenario when the tong experiences more stress than is anticipated. In both simulations, neither materials chosen experienced stress over their yield point. Additionally, a one factor at a time study, or OFAT, was created to determine the optimal first shot temperature before overmolding. Using this OFAT, it was determined that the first shot should be at room temperature when overmolding instead of taking it directly out of the first shot cavity. We would like to thank Bradley Johnson and the Plastics Training Academy for sponsoring this project, Jason Williams for advising us on this project, Chris Bartlett and Andy Bartlett for advice and manufacturing of tooling, PSN Labs for allowing us to mold and conduct our OFAT, and Nicholas Vitelli for advice on design and tooling.